Okay, so this is pretty amazing, actually. I don't know why I just called this amazing. What I would like to do is to start with the 2002 free response question 2, and basically, we kind of did, you know, a lot of this building during period 1, and I'm sure we'll have to go over it again, but in the interest of saving you a little bit of time, I know the class is large and it takes a little bit longer to go through, you know, classroom duties. We'll just kind of read what we have here. So for free response question 1, we have, and again, this is actually taken from an AP exam given in 2002. So while that is a while ago, 12, 13 years, these questions are still somewhat relevant to you, especially in light of the fact that every AP Stat student in the country has access to these questions, and the College Board expects you to study all of them. So we have a manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method, presumably of waterproofing. The appearance of the boots has not changed by either method. The company recruits 100 volunteers in Seattle, where it rains frequently, to wear the boots as they normally would for 6 months. At the end of 6 months, the boots would be returned to the company and evaluated for water damage. So, A, describe an experiment that uses 100 volunteers. Include a few sentences on how it would be implemented. So, did anybody use a completely randomized design? The easiest one to do. Completely randomized design. Nobody used a completely randomized design? Yes. Tell me what you wrote. Okay. Planning on it. I have it written out in my head. So what we have here is we're going to use an SRS to create 2 groups of 50 subjects. Notice the exact method of SRS is not necessary to say, just that you are going to use an SRS to create 2 groups of 50 subjects. Group 1 will wear a new method of waterproof boots. Group 2 will wear the current method waterproof boots. At the end of 6 months, the water damage in each group will be compared. Simple, right? In your head, you should be thinking about what the diagram for this looks like. You won't get any points for drawing the diagram, but it will if it certainly helps you as a thinking tool, then you can write it down if you like. Anybody use a block design? A block design. I'm not saying a block design is appropriate, I'm just asking. Somebody came up with block design here, and we kind of helped here. It was anonymous person's theory that women will take slightly better care of boots than men. Okay, sure. Notice that if you're using block design, you have to have a justification for blocking. So we wrote that justification here. The theory is that women take better care of their boots. Therefore, a blocking will be implemented After separating the subjects by gender, each, and I should write gender block. What did I do? Each gender block will use an SRS to create two equal-sized groups. Quick aside for this, you are not told how many men and how many women are in this survey or in your study. So you can't say how big each block is going to be. You just need to make sure you say equal-sized groupings, and you should be covered for that. One of the groups in each block will use a new method, and the other one in the new group will use the current method. After 6 months, the water damage in each group will be compared. Note it's nice and clean. There's not a lot of redundancy. You mention over here, of course, that each block is separated into two groups, and then you have what each block is going to do. Any big questions on the block design? Yeah. Can you draw it? Yeah, I can draw it. You're going to get a PDF copy of this. I'm going to send you a copy of this.
What's the difference between a block design and strategy?
So that's a really good distinction here, everyone. The block design is an experimental design. Okay, it's the way that you would design an experiment, and we'll draw that in 1 second. That's very distinct from a, well, not distinct, but a stratified sample is the way that you would create a sample. So they're not the same thing, and while you actually have to create a sample for the experimental design.
Oh, so that's
Yeah.
before the experiment.
Yeah. And again, for our purposes, we're not actually going to use a stratified sample for our experimental design. We're always going to use an SRS. Okay. And let's draw a quick diagram for the benefit of the people. Again, like I said, no one's going to actually ask you to draw a diagram. You won't be judged on your diagram. However, since it is something we covered in the class, you should be able to do this at least for class, not on the AP test. So what we're going to do is first we're going to block. I don't know what that is. We're going to identify this as block 1, men. We're going to identify this as block 2, women. I think I need more room. The male block is then going to SRS. Same with the women block, they're both going to SRS. Group 1 is going to use new treatment. Group 2 is going to use the current treatment. SRS. Again, the women block is going to be almost identical. Group 1, new treatment. Group 2, current treatment. We're going to compare. And again, compare damage. Okay. So that's your block design. Okay, was that actually the one that you wanted to use? Well, let's see. Someone else had this thought. I asked if there was a way to do this using a... I asked if there was a way to do this using a, what's the word? Match pair design. Someone came up with this method. We're going to pair the subjects by similar physique. So presumably here, a source of variation would be the body type of the wearer. So I think what they would mean is somebody who is heavier, perhaps, would wear on their boots differently than someone who is lighter. So pair the subjects by similar physique. We'll flip a coin for each pair to separate the pair into two groups. Group 1 will wear the new method waterproof boots, while Group 2 will wear the current method waterproof boots. At the end of 6 months, the water damage in each group will be compared. Pretty simple. Was that the one that they were expecting? No. Let me give you the one that was actually that they wanted to see. Match pair, own control, option 1. We're going to use an SRS to separate the subjects into two groups of 50. Group 1 will wear the new pair of boots for 3 months and the current boots for the second 3 months. Remember that we had 6 months to play around. So the first 3 months, new boots. Second 3 months, old boots. Group 2 is going to do the opposite, where they wear the current treatment for the first 3 months and then the new treatment for the second 3 months. After 6 months, the water damage in each group will be compared. Maybe it's just the water damage for each boot.
Does that mean we can't just say one group wears one type of boot for 6 months?
That one was the first one that we did,
Right,
completely randomized.
So that'd still be okay?
There are better ones to use. Yeah. And I don't remember exactly how they scored this, but I'm pretty sure that if you used a completely randomized design, you didn't get full credit. So they were looking for match pair. Even though they didn't tell you to use match pair, you're supposed to psychically know match pair was what they were looking for. And that still wasn't the best one. According to the people at AP, this was the best design. Okay. We're going to use an SRS to separate the subjects into two groups again. Okay, group 1 wears a new boot on the left foot and then the current boot on the right foot for 3 months. Then, after 3 months, group 1 is going to switch and they're going to wear the new boot on the right foot and the old boot on the left foot. Group 2 is going to do the opposite. They're going to start with the new boot on their right foot, and after 3 months they're going to switch so they have the new boot on the left foot. Presumably that's going to take care of any differences if people are right-handed or left-handed. I guess right-footed or left-footed. Is that a thing, soccer players? Right-footed, left-footed? Mm-hmm. Yeah, it is. It's not?
Well, very much when you start on your left foot, so stepping a certain way.
On the test,
This would have been worth more points. This last one on the AP exam. On my test, I'm gonna try not to be too vague. That's kind of a lie. I'm gonna be vague. I'm sorry.
I can't believe AP didn't get like sued for this question.
They probably did.
Good.
Yeah.
So you're supposed to just try to make the best performance possible.
Exactly.
Why isn't the first one?
The first one wasn't optimal because of a couple things. Because it was a 6-month design, that encompasses 2 different seasons. So we're not exactly sure if there is more rain in one season than the other. Which is why this second one wasn't necessarily as good. This one is better because the idea here is that the biggest source of variation, and I hope you're listening to this, the biggest source of variation in boot wear happens because people tread on their boots differently. So the individuals create that biggest source of variation. And anytime that happens, if the individual is the biggest source of variation, you want to try as hard as you can to find a match pair design for the experiment.
You said the first one law was the seasons, but they're doing it.
I'm sorry, it wasn't the first one. I was wrong on that. Yeah.
The first one, just so you know.
Yeah. The first one, the biggest problem is that it doesn't. The match pair design handles individual variation much better than a completely randomized design. It's kind of this weird gray area because, you know, what does it mean for the experiment to be better or the design to be better? You know? Yeah.
Can you define what exactly a match pair is and why like that one's better match pair than the first match pair?
Match pair just means that we're taking the subjects and they're doing both treatments.
Okay.
So both of these last 2 designs will be match pair in that each individual subject is wearing both the new boot. Yeah, exactly. They're both control and treatment. This one is better than the other one because for that thing that Jessica was talking was because of the seasons, because we don't know which of these seasons is going to be more rainy than the other, and it's possible that there's going to be a big difference. Yeah.
How would you know whether to use like similar groups or own control, and could you use like a similar groups for this one?
Well, this one here was similar groups. No, this one was similar groups here.
Oh.
Okay. And then this one was own control. What I would say is that when own control is possible, it tends to be the better option. It's not always possible though. Any last questions on this? Part B. Is it possible to do a double-blind test?
Yes.
Yes, good. That's what it says there, yes. Remember that we need to make sure that the subjects do not know which treatment they're getting. So in this one, that translates to saying the subjects are not supposed to know which boot has the old treatment and which boot has the new treatment. And that's possible here because the boots are identical. I think that was even stated in the question. The boots are... Where is it? The appearance of the boot is not changed by either method, implying that the boots look the same, new method or old method. Okay. So you can blind them, you just don't tell the subject which boot is which. Yeah, we'll get to that. So in double blind, the person measuring the subjects does not know which treatment is which. And so I wrote down here probably the best way to do that is the boots themselves would be identified using some kind of a serial number or identification number. And The ID numbers belonging to which treatment is unknown to the experimenter and only known to the statistician or the researcher. So in a very real way, the person actually who you go in and show the boots to, the person who measures the differences or measures the damages, they don't know what boot they're measuring. They know the ID number, but they don't know which method corresponds with which ID number. Naturally, there has to be somebody who knows which boot corresponds with which treatment. You can identify that person as the researcher. The researcher should know which boot had which treatment, as opposed to the experimenter. The experimenter is just a grad student who's saying, this boot looks pretty thrashed. That's scientific thrashed. Questions on double blind? Any questions at all on what turned out to be a very long question, right? Yeah. Yeah, I'm gonna email you these notes.
And so the tests are gonna have questions like this.
Yeah, for sure.
Okay, so in one of the other questions on the study guide, it mentioned a comparative randomized design or something. Yeah, what is that?
That's a really good question. The phrase comparative randomized design pretty much refers to any kind of experimental design that we've talked about. They're all lumped together under one kind of experimental design, which is that comparative, a randomized comparative design.
How is that different?
It's like the completely randomized design is a type of randomized, I forgot the phrase, comparative design, yeah.
Okay, so that's just a big, so comparative is just a big umbrella.
The umbrella for all of the designs that we've talked about. Should you write it down? Okay, yeah, Max. In this room, yeah. 3:30, yeah.
And there won't be one tomorrow. There won't be.
There won't be one tomorrow, yeah. Again, this is currently, I don't know, I didn't talk about this yet, but we're kind of taping this right now. This video will be online. You won't see anybody. In fact, you won't see me.
It's just an audio recording?
No, video. It's going to be screenshot. And audio. Screen capture and audio.
Wait, write it down.
Right now. Say hi.
Hi.
See? Samantha's not afraid. She's courageous. Courageous Samantha. That's funny. Okay, so at this point, I want to get to the first 5 questions of multiple choice. So let's get there now. Multiple choice. Number 1 says you are doing a research project on the attitudes. Just gonna kind of wait for it to die down. Wait for it to die. I'm not sure I've ever waited for anything to die before. Well, maybe I have. You know how when you're a kid you're really cruel to things like insects and yeah.
My parents had to tell me to kill it.
Yeah.
That was this whole bit.
I think the cruelest I've ever done was I used to take what is it, hairspray and a lighter and like torch insects like spiders. I guess a spider isn't an insect. It's really bad. Huh? You've never done that?
No, I would.
You would?
Yeah,
Torch
but I've never done it.
torch a spider with hairspray? Okay. You're doing a research project on the attitudes toward fast food and decide to use as your sample the first 25 people who enter the door at Fatburger. Which is the following is true of the sample? And we have the answer. This is a convenient sample. You did no effort to use any types of randomization. In fact, you probably went to the worst place aside from going to a fitness bar. Probably went to one of the worst places to conduct your survey. So, no effort was made to use randomization, so this is a convenient sample. Baram?
I understand that's the answer, but what's the difference between a random sample and a simple random sample?
Yeah. A random sample makes use of any kind of randomized design. So if you remember, simple random sample uses an SRS specifically. So if you remember from when we were talking about randomization methods, we had things like the systematic sample or the stratified sample. Now those are both random samples, but they're not simple random samples. So simple random sample is a special kind of random sample. Yeah?
On the test, are you going to ask us to like know how to do it on our calculator so that we have random numbers?
That is a possibility. Okay, next. How does an experiment differ from an observational study? And the biggest difference between the two is that in an experiment, and I think this is exactly what it says, the researcher needs to impose a treatment. You have to tell the subjects what to do. If you're not telling the subjects what to do and you're just taking the information as it comes, you have an observational study. However, if you're out there and you're manipulating the data, if you're controlling the variables, if you're assigning people into treatment group and control group, you've just created an experiment. 3. Data was collected from 20 cities. Sorry, it says data were collected from 20 cities. That just sounds wrong. Data on the percentage of women in the workforce. The data were collected in 1990 and again in 1994. Gains or losses in this percentage were the measurements upon which the study's conclusions were to be based. What kind of design is this? So the first decision is, do we have an experiment or do we have a observational study? Definitely, observational study. The next thing, since we know it's an observational study, was it a matched pair design? Did we match members in two groups together? Yes. We match the data from 1990 to the data in 1994. For example, if Los Angeles was one of the cities included in the study, we measured Los Angeles both in 1990 and in 1994. And then we took a look at the loss or the gain in those 4-year periods, or that 4-year period. So in terms of, if you want to talk about samples, one sample is the data from 1990, the other sample was data from 1994. Each member of the data set in 1990 could be directly matched with a member in 1994. Namely, the same city is measured at both times. Make sense? Number 4. You want to survey members of senior class at your school, and you want a simple random sample. Okay, so a very specific kind of random sample, a simple random sample. You intend to include 40 students in your sample. Which of the following approaches will generate a simple random sample? Part A, or question A. Write the name of each student in senior class on a piece of paper. Put all the papers in a container and then randomly select 40 slips of paper. Yes, I think I mentioned earlier that putting all the names in a hat is an SRS. So A is the correct answer. A is the SRS. I think it's worth noting what the rest of these are. So let's take a look at what the rest of these are. B. Assuming that the classes are not tracked, select 2 classes at random and include those students in your sample. That's a cluster. We're separating the population into groups, and then we're randomly selecting 1 or more groups to be the sample. Classic cluster sample. Also classic is C. You're going to get a list of all seniors. You're going to select the first 10 names at random. Oh no, sorry. You're selecting one of the first 10 names at random, whatever that means. Then you're going to select every nth name on the list until you have 40 people selected. Because it's not possible to have every combination of seniors in this sample, this is not an SRS. In fact, this is what we would refer to as a systematic sample. You have a systematic mechanism for choosing the names. Generally speaking, it's the every nth name is always going to be a systematic sample. Letter D, bad sample. This is a bad sample. Select the first 40 seniors who pass through the cafeteria door at lunch. Yeah, that's definitely a convenience sample. You did not make any attempt to randomize. And lastly, this is a good sounding one that's wrong. You're going to randomly select 10 students from each of the 4 senior calculus classes. Firstly, we don't have 4 calculus classes that I know of. Secondly, you're actually not sampling, your sample is not going to look like the student population. Your sample is going to most closely resemble the population of calculus students. So this is not a cluster. This is not stratified. This is not an SRS. In fact, it's a really bad sample. I wrote it's a mess. Okay. Number 5. It's a 1, 2, 3 question, which we love. By love, we mean hate. Which of the following are important in designing an experiment? Control all the variables which might have an influence on the response. Yes. We call that the experimental design principle of control. If you have a variable that affects a response variable, you need to identify it and do something to make sure that all subjects react to that variable in the same way. 2, randomize the subjects into treatment groups. Again, that's another principle of experimental design called randomization. Randomization means random groups. Lastly, use a large number of subjects to control for small sample variability. Yes, that's another experimental design element. It's called replication. You're doing the experiment many times with many subjects. So since they are all part of the principles of experimental design, they are all important in designing an experiment, all of the above. And that's kind of where we're going to leave it. Any questions on what we've covered? Yeah?
What's the difference between an SRS and just a regular
Yeah. So what we were saying over there earlier was that an SRS is a very specific kind of random sample, and the biggest distinction is that in an SRS, every possible subset could be chosen. So it was person 1, 2, and then person number 93. They could all be part of the same sample. Now, if you use a simple systematic sample, that's not possible. So SRS is a specific kind of randomized sample.